So let's solve this exercise. Ascorbic acid or vitamin C is an essential vitamin. It cannot be stored by the body and must be present in the diet. What is molar mass of ascorbic acid? Vitamin C tablets are taken as a dietary supplement. So as we see here, there is the first question that needs to identify, find, determine the molar mass. The second question, we need to find the moles. And the last question, we need to determine the number of molecules. So let's go to the first one. What's the molar mass of ascorbic acid? In order to solve this equation, we have the formula and we have their atomic masses. So we need to combine them, and molar mass of C6H8O6 will be. So you're gonna multiply by their atomic masses. That's a C plus H is times 8 plus, and the last one is oxygen, which is 16 times 6. Please be sure to identify it by significant figures. It means when you adding them up, you look at the decimal places. If you see carefully here, we have decimal places 2, we have 3, and we have 2 here. So our answer should contain 2 decimal places. So we can take calculator and solve it by using it. Times 8 plus 16 times 6. And you will get the full number is 176.124. But we need only 2 decimal places. It's 1 and 2. Do we need to round? No, we do not. So we're going to leave it as 176.12 gram per mole. That will be our answer for the first one. Now the second one, if a typical tablet contains 500 milligrams vitamin C, we will do dimensional analysis in the situation. So we're gonna start with 500.1 milligram C. And how many moles of vitamin C in the 500 grams of milligrams? First of all, we're going to convert that to grams, and in order to do that, you need to write here 1000 milligrams and here 1 gram. The next step will be defining because it's gram here should be gram, here should be mole. What you found, 176.12, and here's 1 mole. That's how you will find the mole. Let's cross out some units. Mg is gone, G is gone, G is gone. So what you have is so what do you have? 2.838973 and gone. It's kind of huge number, so minus 3. That's small. Okay, what we need to write? We're gonna look by how many significant figures in the beginning here. So we have 4 significant figures, 1, 2, 3, 4, because we have decimal point. That's why we have 4 significant figures. Our answer should contain 4 significant figures as well. 1, 2, 3, 4. Now we need to look at the next number after 8. Since it's 9, we need to round that 8 to 9. So our answer will be 2.839 negative 3 mole. That will be our answer. Now the third one, they're asking you about what number of molecules, and since it's a called number of molecules, we need to use Avogadro number to solve that equation. Okay, we have this mole, we can use this mole for the third one. 2.8 839, 10 negative 3 moles. We need just to convert that. And we know that 1 mole always is equal to 602 times 10 to the power 23 molecules. I'm gonna cross out mole, and I'm gonna find that 839 times 602. So what I have in the beginning, it's when you do the multiplication, you will do the following number. Now we cannot display this as a number because it's not according to scientific notation. So we're gonna move this decimal point twice to make it 1.7, right? Now we need to look at how many numbers are there as significant figures. Since your problem starts with the 4 significant figures, your answer should be always be 4. So we're gonna take, which ones we're gonna take? We're gonna take 1, 7, 0, and 9. And 1709, yes. And after that you're gonna write here 9. You don't need to round the 9 times 10. Since you move 2 twice, this will go down. This will actually increase to negative 21, and this will be number of molecules.